of a program, together with conditions, together with if, elif, else statements. Okay, we have two instructions, two statements to implement iterations. We first study the while loop, and in probably next time we'll discuss the other way, which is the for loop. There are some differences between the two statements, but the effect is pretty the same. We have namely, we may reproduce some iterations. That's to say, we have a bunch of lines of code which will be repeated as many times as we need. There are differences between the while loop and the for loop. We begin discussing the while loop. Okay, this is called also a conditioned loop, because the iteration may take place if and only if a condition is true, and the iterations will continue to be executed while the condition is true. When the condition turns to be false, the iterations will be stopped, will be executed no more, and the execution flow will skip to the first instruction outside the for loop. So the idea is that we have a condition. We determine whether the condition is true or false. If false, we exit, we do not execute. Otherwise, we execute the instructions contained in the while body, and at the end of every iteration, we check again the condition and continue to iterate until the condition turns to be false. An example. This is a very simple example. This is a countdown function in which we have an argument which is n, and this is how a while statement looks like. There is the while, a condition, and a comparison, and the colon, and then we have please, for some typeset error, there is a wrong indentation. The lines are too many indented rightward. So please remember that the indentation is still always 4 spaces. Okay, so here we have kind of 8 maybe, so it's nonsense. Okay, what happens? While n greater than 0, the instructions contained in the while loop are the following: print n, and this is a very concise and may appear somewhat obscure Python instruction, which is n minus equal 1, means it's precisely the same as n equals n minus 1. Okay, so the idea is to decrease the value of n and replace n. Okay?
Well, is equal to n equal to?
n minus 1. So what happens is that we carry out, suppose n is 4. Okay, we initially check whether n is greater than 0. The result is yes, so it's true. Therefore, the instructions contained in the while body will be executed. So first of all, we print n, namely 4, and then we decrement the value of n, which is now set to 3. We go back to the comparison and check again. 3 is larger than 0. The answer is yes. Therefore, we print again. We decrement again. Now n is 2. We go back to the check. 2 is larger than 0. Yes. We print it again. We decrement, and now is 1. 1 is larger than 0. We print it. We decrement. Now n is 0. We check again. Now the comparison returns false. Therefore, the instructions in the while body will not be executed. Instead, we skip to the first instruction outside the while body, which is now here. So go. Okay. Is it clear for everyone?
Yes, yes, Professor.
Okay, so let's count down n. Okay. Okay. So what happens? We print the first value, the original value of the argument, which is 5, then 4, 3, 2, 1. Finally, we decrement n, which its final value is 0. We can print final value of n. Okay, final value of n. N is finally set to 0. The condition is false, and therefore the while loop will be executed no more. Instead, we print this instruction and this one. Any guess about this none? Yes. That's right. So the function is a void function, which returns nothing to the and therefore when we print the content, the return value of the function, we have none. Is it clear for everyone?
Yes.
Hello.
Yes, it's clear.
All of you?
Yes, it's clear.
Yeah, is it clear for everyone? Any question? Okay. There is an important warning, which is fundamental for the correct functioning of the while loops, which is we must modify the value of the variable present in the condition if we want the while loop to end. Suppose for a moment we do not update the value of n. Sorry? Yeah. Why?
Because the end will be always, the value will be always true, so you won't go again.
So it never would reach the n equals 0, which is the final value. Okay, it would run. See, n is never updated. You see, look near in the square brackets there is an asterisk which indicates that the program is running. Okay, so it wouldn't stop. Now we have plenty of 5 in the output. The value is never updated. And of course, the result is that the while would never stop. Okay, so the question is, be careful. The point is, be careful with updating the value of the variable, the expression, whichever, which you check, the truth of which you check in the while statement, because depending on its updating or not updating, it depends the finiteness of your while loop. Okay. Here is another example. I'm sorry for this foolish behavior of this indentation, which is somewhat disturbing. This is another example. We have a function called sequence, whose only argument is n, while n is different from 1. So if n is even, modulus 2 equals 0, namely if n is even, divide n by 2. Otherwise, replace n with, so n would be odd. Okay, if n is odd, we should multiply by 3, add 1, and replace n with this new value. Let's suppose if n is 4, for example, let's say, suppose n is 6, which is more meaningful. If n is 6, this if is true, we divide it, and now n is 3. Okay, we print it, We check again. Now n is 3, is different from 1, so we go inside. Is it even? No. So what happens is we multiply, we skip, we execute this instruction. We multiply 3 by 3, 9, plus 1, 10. We print it. We check again. Now is different from, is still different from 1. Is even, so we divide it by 2. Now we have 5. We print it, and so on. So apparently it would never stop. Actually, what happens is that it continues oscillating between even and odd values until we reach a value which is a power of 2, which as a consequence, as the fact that we always will enter the if clause, divide by 2 until we get 1. Let's check it. Def sequence n. So while n is different from 1, if n modulus 2 is equal to 0, n. Do you remember what's the meaning of this symbol? Oh, okay. Nothing more. Okay. This is what happens. I insert. Let's try with 6, which is the one. Oh, okay. We first divide by 2, and we get 3. The next iteration, 3 is odd, so we multiply by 3, add 1, we get 10. Next time is even, we divide by 2, we get 5. Next time is even, we multiply by 3 and add 1, so 16. And now we got of 2, which finally is the correct way for ending the iterations, because now we always divide by 2. Okay, let's suppose we get 7. Okay, look, we finally end with a multiple, with a power of 2, which finally produces only divisions by 2 until we get 1. Here with 7, we have a little bit of more iterations, because it's 7, it's odd, so we get 22, then divide by 2, 11, then 34, then and so on. Okay?
So when I apply this function and I run, I get an enormous multiple numbers.
Any mistake? Any change in the code?
No.
Oh my God. Stop it, please. is equal to 0. The n modulus 2.
Then we use minus.
Okay. So you should check that
The L9.
online students, have you done?
Yes,
Yes.
Professor.
Yes, we done.
Any problem?
No, all clear.
Sorry? Just a joke. Okay. In some situations, it's useful to insert some termination condition. Suppose we are searching for a word in a text. Okay, so the first occurrence of our word should it's enough. Okay, there is no need to or we are searching for a number in a list of numbers. The first time that we get the number, we should stop. There is no need to analyze all the remaining numbers in our list. Okay. In such cases, it's useful to insert a break statement which stops the execution of the while loop. So the current iteration is stopped, and no further iterations will be executed. In this example, apparently strange condition, which is precisely what you have in codes, for example, waiting for you to insert a correct word or your correct datum and so on. So the first instruction reads while true. While true means that there is no condition at all. So while true means that this is an infinite loop. It should never stop because there's no condition whose status could be changed. Look, in the previous example, this was a condition depending on the value of a variable. If it happens that n is equal to 1, the condition is false and the iterations are executed no more. In this case, there is no such a situation. Condition is always true, so potentially this is an infinite loop, which is precisely what we need in some situations. In this case, what we do is to wait for the user to prompt a string, and we if line is equal to done, we break, namely we stop the execution of the while loop. Otherwise, we print the line and we go back. The condition is always true. We wait for another line. We check with done, and so on until the user eventually inserts done, meaning that he wants to exit to complete the iteration. Is it clear for everyone? So, while true is the signature of a never-ending loop. So if you want to allow your user to insert as many numbers, as many lines, as many elements until it reaches, for example, guess a number. Okay. If you want to code a guess a number simple program, you have to code a while, a never-ending while statement, which eventually breaks when your user guesses the right number. So while true, line a word, okay, this is how this small program works. Needless to say that we wouldn't insert this conditional. The while loop would never stop because there is no escape condition, there is no termination condition. Okay. Is it okay for everyone, online students?
Yes.
Yes.
Okay, so it's time for a review. Okay. So, write a small a fragment is a piece of code. I mean, there is no structure, just the interesting instructions lines. You should require the user to insert a number, and then you iterate until the user inserts 10, the number 10. Okay? Is it clear for everyone at home?
Professor, can I share my screen?
In a moment, please.
Okay.
Sorry? Okay, go ahead, online students. Your solutions?
Yes, Professor.
No. If I insert 12, I mean any number can be accepted. Okay. Any other?
Yes.
Come on.
Yeah, I used
Okay. Okay. Any other? Okay. So your solution. Check only there's no need, I mean, as short as possible. Wow. Okay. Are you bold? Why doing this? Okay. Okay. What do you think? Where? Where?
Yes, because you should ask, you should place the input inside the variable. Otherwise, we never comply it. So you must ask for the values. This is another radio. The radio I asked was about asking as many times the user to input the number until it's equal to 10. So no loop is needed to modify the numbers. Okay? So we have to ask again and again and again and again until eventually the user the correct number. That's very important.
Any other? Any other online student has carried out the review? Hello, are you there?
Yeah, okay, Professor. Just one second.
Yeah, Professor, but my code isn't working.
Okay. Let's give a look at your code. Okay. Okay. My suggestion is to stop. Press the square button. There is a black square on besides in order to stop your code working. Okay. You should be careful about indentation. You cannot place all your codes beginning at the same column. Can you hear me?
Yeah, Professor.
Okay. Okay, an interesting and useful module we can use and will use in some applications is the random module, which is pretty useful because it contains some functions which deal with random numbers. The instruction to have at end all these functions is it's of course the same, import random. And for example, we may, if if you Google random Python random module, you will find a lot of useful information and a lot of useful methods, functions. For our purposes, we'll use the rand int, which is a function which produces a randomly picked integer number contained in the range you provide. So, for example, print random.randint, let's say 10, 20.
Can you share your screen?
Yes, sure. Here we are. This is how to import the random module. And this is the instruction. So, for example, if you invoke once more, you will get a different number. Please note that, of course, as this is a random number generator, you will find always different numbers. Of course, the larger the interval, the larger the possibilities. If you pick if you need a number in the range 10, 11, you have no, okay. But if you pick 10, 50, let's say, you will find okay. Very well. Sorry?
It's more complex to find the twice or 3 times the same number.
Yes. Okay, so now we'll use this function, this module and this function to reproduce the previous review, but without an insertion from the user. So you have your magic number, which is 10 again, and let's say you have yes. Sorry, can you repeat?
I mean, it's random. Is it module or?
Is a module, yes.
Mass also a module. We also import the mass. We can import mass, random, and
there is plenty of modules.
What we importing is random, module.
Again, please.
What we're importing from somewhere, is it module or what's the name of this random?
Random is a module. Okay. Let's which contains what follows. There is a list of functions. Okay, which are useful for different applications. For example, the basic is this one, random, which produces a random number in the interval 0, 1. Then you have, for example, randint. Then you have, for example, choice, in which you provide a list of numbers and you tell this function pick at random one of these numbers. or choices, which, if I will remember, does the same, picking as many numbers as you need. Let's say you have a list of 1,000 numbers, and you tell this function pick 10 numbers out of this list. So
all are modules, yeah?
these are actually, they are functions contained in the random module. Okay, so a module is a container. Okay, you can create your own by simply placing inside the file all the functions you created so far, and then you baptize this file in such a way. Okay, and from another program you may import, yes, the module you created, and every function therein contained will be invoked with the name of the module, which is the name of the file without .py extension, point the name of the function. We'll see how to create a custom module and how to invoke a function. Okay? Okay, so this is how random.randint works. So repeat, write another Python fragment which iterates until the output of this function equals your magic number 10. Is it clear for everyone? Yes. Let me type this. Remember, please, that import random must be invoked just once, so do not insert import random inside your while loop. Okay? Is it clear for everyone at home too?
Yes. descending here in these areas. That's why we get a two choice.
First of all, the point is that the distribution, the first division produces a global point number, so you will never get that it's equal to 1. This is why this is you invoke power from inside power, but you should store the third value. Yes.
I mean, it's like the reduction is ending on this one. That's the problem. It's not ending like here or here. Because if it goes ending with here, it should be really good.
So try to no. The third power AB.
So I will do this thing.
Yes. But without invoking it,
Would we want to break this rule?
Yes, no, it's the same. The point is that you produce something and you think, yes, but you do not return back the quality function.
So basically, I will call the function instead of in the return.
It's still the same idea. You execute something and which produces some value. So it's necessary the function to be a fruitful function, and then you return its value. It produces something and you can return. You're welcome. What about this Edudan? Does it work? No, any problem? Do you need more temperature in order to use Nigo? I think Nigo claiming they are weak. if the temperature is not lower than 25 centigrade. But I mean, today we are more or less there. Now you have to produce your integer random numbers inside the while loop. Or otherwise, you cannot compare with 10 and eventually stop. Have you done? What's the temperature here? Yes. Oh. Do you increase the southern part or the northern part? Southern part, which state? Andhra Pradesh. Does it here go to work? Okay. And which is the temperature? Do you need any special things? Which is the name of it? Does it work? Okay. You know, the problem is that nobody can come in because the door is somewhat locked. I mean, maybe it's late, probably nobody will arrive, but okay.
From the having called.
Yes, yes. Okay. Your solution is
I will
Can you? Can you done? No, place input outside the way. You have to input just once, or otherwise you overload your code in the okay. Online students, have you done?
Yes.
Sorry, Professor. Could you show last example? I lost my connection for last 20 minutes.
Which one? Have you done? Okay, any success?
Can I show my screen?
Sure.
I did it like this.
No, there's no need to. Oh, okay. Yes, actually, yes. Okay. Okay.
Because I use the
Yes.
A.
Yes.
Okay.
Okay. Very well. Any other? Okay. Nobody else?
finisce
the direction that the program did, if I want to count the direction that the program did to before finding the 10, I can implement the count, or maybe there is a function already inside the random.
Sorry, can you repeat?
I was saying that if in this review that you did now, if I want to count the iteration that the program
I call the method and there is H1.
Of course, it depends.
With a count. With a count.
Just should count
And then thank you.
Okay, it's okay. Very well. Okay. So, of course, depending on the history of the random number generations, you may have a larger or smaller number of iterations. Okay, it's a simple way to count. Probably no. Okay. And now let's begin. Another topic. We have 30 minutes, and in this we begin working with sequences. There is Python has a large number of sequence data types. We'll see for different reasons and with different levels of detail, strings, which are sequences of characters, lists, which are sequences of possibly heterogeneous objects. In a list you can place numbers, characters, strings, other lists, and so on. Unlike C arrays, which must be defined with a very precise data type in mind. You can define an array of unsigned int or long int or floating point and so on. In Python, you can place into a list different types of values. And then we'll see other, we see tuples, sets, and dictionaries, which are other sequences. This is the first one. There are some common features for all sequences, which makes their use pretty simple. So of course, there are some peculiarities, but there are some common features. Okay, why do we study strings? Because they are possibly the simplest sequence types, because their use is as common features together with others, and so it's useful to study them. Let's define, for example, the definition. A string is a sequence of characters. You can access each single character using its an index which denotes its position inside the string itself. So, for example, if you define a string which contains the character which is composed of the characters "hello everybody," you can define, you can pick a single character or a substring using this notation. So str1 square brackets 4 is the character with index 4. Keep in mind that indexing, as in C, starts from 0. So the first index is 0. So if you ask for the str1 with index 0, we'll get capital H. This is 1, 2, 3, and 4. So the output of this statement would be regular O. Okay, and so on. Okay, of course, the expression in brackets is called an index, and the index denotes which character is requested, which character you want. Sorry? Yes.
Spaces between words are also considered as characters.
Yes. Yes. Anything enclosed in single or double quotes is part of a string. Numbers, punctuation marks, spaces, anything. So, str1 equals. Do you remember that strings can be defined using single or double quotes, which is up to you? Hello, everybody. Print str1 4. Okay? Is it clear for everyone? Online students, are you there?
Yes. Yes, it's clear.
Yeah.
All of you? It's okay? Very well. Okay, there is a very useful function which is len. It's a built-in function. You can apply to all sequence data types. So we begin applying it to strings. And it returns the number of elements contained in a sequence. So in this case, the number of elements contained in the string. Print len str1. So we have 15 elements. Please be careful with using the return value of len, because let's use this way. Let's suppose that we do something like this. And then we print str1 of n. Which effect do you guess will get, and why?
Because the number that will give us the string length would be the length, of course, of the string. Let's say in this case there was 15 characters. But if we print let's say the cell 15 in our array of characters, it will print basically the one character most. Is the ending character of the string.
No, it's not the ending. It's beyond. It's beyond the end. Remember that 15 is the number of character. It's not the index of the last one. If you start counting from, if you start indexing from 0, your final index will not be 15. Rather, it will be. It will be 14, of course. Okay. So we get an error, and we are said index error, string index out of range. Okay. If we use n-1, we get the final y, so the correct last index. So always remember to be careful with the indices in your sequence. Okay. It's okay for everyone?
Yeah, Professor. Just show the code, please.
Am I not sharing? Yes, I'm sharing. Do you want to share your code?
No, I want to see your code.
Yeah, it is. This is our string str1, and this is okay.
Okay, Professor.
I've noticed that it is possible to do basically everything in a line. So we can print the character of length inside the string 1.
Yes.
It's a bit unreadable to say.
Yes, of course. This is why I used an intermediate variable n, which could be avoided. I mean, I could ask print str1 of len str1 -1, but it's not very clear. It's rather obscure. Of course, it works. And it's more effective to carry out to use this code style because you do not insert a new variable, so you do not a memory location with a meaningless variable, okay? But there is not only efficiency, there is also readability in a code. So this is why, okay. Okay, we can process a string one character at a time. We can begin from usually we begin from we start from the beginning of the string. We select each character. We do something, and the process continues until the end. The end. I'm sorry. This kind of operations is called traversal because we traverse all the sequence. Okay, in this case, we have an example of this way of processing sequences. We define a string. I wander lonely as a cloud. Does anybody knows this? What this line refers to? What does anybody know? What this line refer to? The string.
It's a sentence from a film.
A sentence?
From a film.
No. It's the first line of one of the famous poems in English Romanticism. It's a poem written by William Wordsworth, who was one of the late poets who began the English Romanticism movement in poetry, together with his friend Seymour Taylor Coleridge. And this is the beginning of one of his most famous poems. I wander lonely as a cloud that wanders in. I don't remember. And it was used in a song by Genesis. Do you know Genesis? Have you ever heard? No, never. Nobody. Oh my God. Okay. Okay, so let's give a look. Sorry. Other times. So this is a string, by the way, and this is how we can traverse it and doing some processing. We initialize an index to 0. We initially set to 0, and while I is less than len of the string, so while I is less than the length of the string, we pick the ith element of the string, we store into a variable which is called letter, by the way, and we print it. Then we increase the value of I by 1. So we initially have I equals to 0. At the end of the first iteration, it will be 1, and then 2, and then 3, and then 4, and so on, until we arrive to the end. When we finally have that I is equal to the length of the string, this condition will be false because it will never be less than, and the iteration is stopped. This is an example of traversing, of sequence traversal. We select each element at a time, we do some process, and we next element of the sequence, and so on. Any questions? Is it clear?
Is it possible to increment the index inside the assignment? Like when I have letter 0 to 3 weeks with...
Yes, but you wouldn't start from the beginning. If you place I plus 1, the first element would be the second. Okay? And the last one would be outside the boundary of the string, so you would eventually get an index error again. Also, be careful with limits of your iterations. You must be careful about I smaller than, less than len. If you place equal, smaller than or equal to len, you will get an index error. And this is what happens. Now I am doing two new things. The first one is to insert a strange character, which is backslash T, which stands for insert, a tabulation. Okay, so there is a fixed number of spaces between the first character and the second one. This is and here we have an example of a string built-in function which is directly available for use. And in this case, the function I decided to use is APA, which, as the name states, simply converts the string into uppercase. Be careful, we are not changing the string. We are changing, actually we are not changing anything, but in any case we are asking to be converted the ith element of the string, which has been stored in the variable letter. So it's letter that is converted, the content of letter that is converted into uppercase. Okay? And if we print string x, we can check that it didn't change, and it wouldn't change even if I slightly modify this code this way. So without adopting an intermediate variable ladder, I decide to print the ith directly the ith element of the string and to convert the ith element of the string. It works. Still, the string is not modified. So the effect is that we select the ith element of the string, we print it, we convert to uppercase without any alteration to the original string. Because, be careful, there is no assignment, okay?
So basically, what the program needs is to convert the letter from lowercase to uppercase and then delete what it is.
Yes.
It's not storing the
Yes. Yes. Any potentially, in principle, the change could be done string x 0, for example, equal I. So I modify. I don't want to capitalize the sentence. Rather, I am assigning to the 0th element of the string another value. This is, in principle, how to modify a string. But you'll see in a moment that this statement, this instruction, will produce an error because strings cannot be modified. Are immutable objects in Python. They cannot be modified, they cannot be changed. Bada boom. Does not support item assignment. So you cannot modify a single elements of a string, which can be rephrased saying that the square brackets operator cannot stand on the left-hand side of the equality. Okay, so you cannot modify a single element of a string. There are some other examples of immutable objects in Python, such as, for example, integers. Integers cannot be modified. I will show you in a moment this way. Let's define a simple integer number. Okay, here we have some information, which is the content of the variable, which is 12, the type of the variable, which is an integer, and a strange number, which on Linux boxes such as mine is somewhat related to the memory location of the datum. So where in my memory, more or less, where in my memory the number 12 resides. Okay?
It's pointer instead of.
Sorry?
It's
kind of. Okay, let's do $20. We change the value. What happens is that it's still, we have a new value, we have type of datum, but we have a different identifier. We have a different memory location. Okay? Why? The same applies to floating points. Why? Because integer variables, integer objects have been defined, have been declared as immutable objects, and when you update an integer value, variable, what happens is that you destroy the old one and recreate it with the same name.
But this is not
It's a different. It's a. Sorry.
In string, this does not happen.
In
Strings.
in string is still the same. If you define a string. This is what happens. Okay. It's a different identifier.
No, but I mean, with integer, I can assign, I can modify, but I cannot modify one of the two numbers.
Yes, of course.
Because before we try to modify just
It's a single number. You can. It's a single memory location. You cannot modify single figures, the single digits.
same thing for this.
Yes. Okay. Any question? Is it clear for everyone? Okay. It's clear for everyone at home too?
Yes, it's clear.
Yes, sir.
Okay. So, if there are no questions, I should stop. I should stop here. So see you tomorrow at 9 o'clock. Have a nice day. Bye.
Buona giornata.